This video is going to go over process parts 3 and 4. You'll need some scissors and some pieces of paper. I use cardstock for this part, so you must want to have those ready to help you do this part. Alright, process parts 3 and 4 have us going through and doing the actual work of creating the Marshons. So what you need to do is figure out, well, we did probabilities in the first step, and this is for both F1 generation and then creating the F1 generation and then creating the F2 generation. So we're only going to be focused on crossing the first two parents, right? And you can see this in the example pedigree here. You've got the male and the female. We know what their genotypes are. We know what their characteristics are going to be. We've already figured that out in the process steps 1 and 2. We did the probabilities. Now we're actually going to do the actual. What do their kids actually look like? Right, and you can see this class has already done this because I took this from another class, and we're going to show you using chromosome paper cutouts how to figure out actual outcomes. All right, so I'll show you how to cut the paper and fill out the alleles and things like that. But what we're going to end up with is this, right? We already have these individuals. We have Barb, Bobo, and Blater are the offspring, and here they are: Barb, Bobo, and Blater. So they were already produced by this couple, and we'll show you how this group got those and how do we maybe make another offspring. All right, you only need to make 3, and you'll be saying, wait a minute, don't we have 4 because of 4 outcomes? No, remember, it's just probability is based on Punnett square. Actual outcomes are going to come through this kind of process. We know that meiosis requires alleles to be split, right? Chromosomes from mom and dad are being separated from each other, and this process will help us to show that occur. All right, so let's take a look here. We're going to go through this process. So we're going to get our pieces of paper, and I'll show you how to go through each of these steps here. You can read it along as I show you in the screen. All right. Alright, so here are my pieces of paper. I like using cardstock. It's nice to use those. I have 2 sheets. I'm going to use one for the parents, my P1 generation, to make my F1 generation, and the other one's going to be my F1 generation making the F2. I'm going to set that aside. I need a pair of scissors, and I have a cup that I'll use. Alright, so the first step is you're going to cut these into somewhat equal strips. I'm going to need a total of 5 per parent. So I'm just going to cut them up pretty quickly here. It doesn't have to be perfect. This is just going to help us control chromosome inheritance. 1, 2, 3, 4, and a 5th one, just to make it even. I'll cut this one up a little bit shorter. There we go. Now, I need 5 per parent, so rather than cutting out another next card, let's cut these in half. You can use whatever you want. Scrap paper, you just need 2 sides that you can write on. So that gives me a total of 1, 2, 3, 4, 5 for the male, and 1, 2, 3, 4, 5 for the female. Okay, that's the steps that you'll see there setting this up. Now what you do is write the alleles for each of the parents on the card. All right, so I'm going to show here on the screen what we figured out in the first set of the process. All right, we have male and female, and what we need to do is write down the alleles, one on each side. It's a 50-50 chance that a male or female would end up with those genes. So let's do the male first. Females will sit down here. All right, so the male, as you can see, has a 1 chromosome, an X with a superscript E, and a Y. We know that males have the Y. All right, so X on one side, Y on the other. That gives us 50-50 chance, no matter how that card lands, right? Whatever's showing up is the allele that I'll have, right? Not only is it X, but it also has a superscript big E on it. All right, so that's X, Y. The next allele that we need to look at is long legs, right? Big L. Big L on one side, big L on the other. And then we got feather color. C with a superscript B on one side, another side, C with a superscript B. All right. Next allele, we've got accordion outstretched. So one is a capital A, the other side is a capital B. Only 1 allele per side because it's going to be 50-50. And then no wings. Try and show a capital W. I like putting these little lines on it, show that it's a nice big capital letter. And that's it. You can double check that you've got all of them written on both sides. So if you do that, right? Oh, I missed this side. So this is a good double check. Right, that you've written on every side. So double check that there's an allele on every side of our chromosomes, and the male is good. All right, so this is the male. We'll put those aside for right now, and here's our female. same process. One allele on each side, 50-50 chance that their offspring will have one or the other, depending on how they land. Females are 2 X's, X on one side. This is our sex chromosome, X on the other, right? She's a carrier for 2 I's, but she shows only the one. So there's the dominant characteristic, and here's the recessive. This has to be a lowercase e. Female, all right. She, just like her mate, has 2 big L's, all right. And then we've got feather color is also blue, C with a superscript B, C with a superscript B. Mom has accordion arms only, little a, oops, I made a mistake, little a on one side, right, little a on the other. Gotta be careful, that happens sometimes. Just gotta fix your mistakes. All right, and then we got lowercase w. So do something to show lowercase w. I like to use like a little script, like that. So I know the difference between my capital and my lowercase. And there we go. So we can double check again like we did with the other one. Make sure both sides have an allele on it. All right. Oh, there was my mistake. That's good. All right, everything's got something written on it. So we got dad, we got mom. You can shuffle them together, right? If you have a cup nearby, it's helpful to have the cup. Insert your chromosomes, right? And when I used to do this at my old school, the kids coined it sex in a cup, because what it does is it helps you to randomize the outcomes of the kiddos, right? Shake it around and dump them out. And what you end up with is a new individual, right? Sperm and egg have joined. Alleles can now, chromosomes can be organized, and you can actually see what the results are. So let's see what we got. So the siblings are already Barb, Bobo, and Blater. So do they have a brother or a sister? Well, let's see. Well, boom, we've got a sister, right? So Barb, Bono, Blater, and now we have a new sister. Let's go Bonnie. We'll stick with the B's. All right, so this is Bonnie, right? We know Bonnie. We know her genetics. She has, unlike her sibling, she actually has. Oh no, she does. She has she ends up having 2 I's, right? So we know from the genetics that 2 I's is going to be lowercase e. Oh, they all have. This is actually a mistype on here. These are actually all supposed to be 2 from the siblings. From their genetics. We'll fix that. All right. So she is going to have, she has a big E and a little e. We know that dominant is 1-eyed. So unlike her siblings, she's going to have 1 eye, which is dominant. And she's going to have this as outcome. She's got X with a superscript E, X with a superscript E. All right, she's 1-eyed, and she's female. Let's see what we legs now. Let's see, we got L. Both parents had capital L, so this should be just like their brothers and sister. 2 big L's. So it is long legs. She has 4 fur color, feather color on my so we got C with the superscript B, C superscript B, just like her brothers. See, I'm just copying and pasting to make that easy for me. And then for arms, she has A, that's a capital, and a B. So she's just like her one brother that has accordion stretched. And then capital W, lowercase w, having no, the dominant means no wings. And it's just like the rest of her siblings. All right, so we can actually now create Bonnie, right? So if we were to look at the actual pedigree, right? We see Barb, Bono, Blater, and we can add Bonnie now to that. So you can go through and actually create them. Right, we have our Clipart to help you do that. Right, you have your pedigree. Right, so there's P1 parents. Right, they create 3 offspring, which you have to create using this method. And then to get to this part, you have to create an individual. You can create whoever you want to be the mate of your 3rd kiddo. Right, they're going to mate and have 3 kids. So you have to do this whole process with the chromosomes twice. That's why you need a second card, because you would do this again with the kid, right? So whoever this person is in the pedigree, they're going to have their mate, and you create that person. You can create that monster. If it's a male, you have to have a female, obviously, for the genetics to work correctly, and they'd have 3 kids. So whatever ends up being, you create your own. So if we take a look at our steps again here. Right. Step 4 is to actually create that pedigree on the Google Slides. Right. So you can see how we did that in previous class, and that's we added Bonnie on there just now, but we didn't create her. But you have all that clip art that you can use on the clip art page to create them. So I've given you this to work with, and you can use other ones from the internet. There's lots of clip art out there on the internet. The internet GIFs are pretty cool to create your very own. All right. Well, good luck on creating your pedigrees, and that is the end of process 2. Remember, you got to do this twice. Do it for the P generation and for the F1 generation to have grandkids for your original parents. All right. Good luck. Email me if you have any questions.